Good evening, all. Hope I'm audible. Uh, Welcome to the continuing session for P&IDs. So here we'll be mostly discussing about few concepts which are important for process safety and safe operation of the plant. How these concepts are captured in P&ID. So just a recap of. So this is just a recap of what we understood in the last session. So P&ID shall include the following. These are the main things to be included in the P&ID. Latest revision with date and scope, and if you have made any changes, that is to be clouded. That is for easy identification of the changes. Process flow with the flow directions of the fluids. Equipment details including tag numbers, capacities, dimensions. Piping size, class, specifications clearly mentioned. Instrumentation including the control scheme and shutdown systems. So both these 2 points we'll be discussing in detail today. Equipments with isolation and bypass valves clearly shown. Lock open, lock closed valves. Few valves needs to be kept open for the process and few kept closed for normal operation. That is to be mentioned in the P&IDs. Slope of the line to be mentioned. Drain line, vent line, wherever it is available, it has to be clearly mentioned. Vendor packages, whether it should be clearly demarked so that we'll know the scope from where the vendor package starts. Insulation or tracing details. And special instructions in notes. So in notes, special instruction, this is very important. This is the last fact we discussed in the previous session. In notes, we'll have different informations or important facts which are to be considered for further designing or further engineering, and also for normal operation and maintenance. So all these special instructions should be captured in notes, and those are to be clearly read and understood. That is important. So today we'll be focusing more on special piping arrangements and control systems. So piping arrangement, these are the main things for process safety. So we'll be focusing towards process safety, positive isolation, piping spec break, pressure safety valves. So we will not be getting into the design details. We'll be seeing the base facts and how it is given in a P&ID. So positive isolation. So that is once it's like you can it's analogical to closing the door of our house. So we have two types here: positive isolation, valve isolation. Valve isolation is just putting the lock, closing the lock in our house door. Positive isolation is putting that additional lock for securing. It's like once we leave our home and we go for a vacation, or sometimes we will put additional locks, right? And that is positive isolation. So that will not allow inadvertent opening of the door. So same here. So positive isolation is used wherever containment is required, or there is any other stream chances of other stream getting into the process stream, or whenever equipment is to be isolated, taken out for maintenance exclusively for man entry, where person has to enter inside the vessel for any maintenance job, inspection, everything. There we have to positively isolate. So we'll also see in coming PPTs what is positive isolation, how it is given in P&ID. And valve isolation, it is given only for a less difficult maintenance task or a precursor to positive isolation. So this will be the first isolation, and then we'll be provide positive isolation. So positive isolation shall be provided where the duration of maintenance will be longer than a shift. So basically it provides the required safety. So it will not allow the process fluid to come into contact or come out of the pipeline. And positive isolation will be provided at facility limits. So every unit will have their own boundary or limits. So in the boundary, you will have entry exit of all the process fluids. So where in that place, positive isolation will be provided. So in case of any unit shutdown, so you'll isolate the entire battery limit, isolation walls, and provide positive isolation. So this we discussed. Positive isolation is given for battery limits, pigging assembly, all the vessels, pumps, compressors, filters, everywhere positive isolation facility is provided. So now we'll see what actually it is. So these are few examples. The first drawing, if you see, it's an online process, it's an offline process. So from online process, fluid should not get into offline process. Offline is mostly used only during the shutting down of the unit or after shutting down the unit. So we'll close the valve here and we'll provide a blind. Okay. It is like we'll close the valve, we'll remove the spool. So here the connectivity is disconnected in the second example. So this again gives a positive isolation, that is fluid from online process will not get here. Double block bleed plus spectacle blind. So here I have two isolation walls. So increase the chances of decrease the chances of this process fluid getting down here. So you have provided two walls and a blind flange. Here you have provided two walls with a removable flange. So here you have a single wall and you have provided a blind. Okay. So these are the different kinds of positive isolation, and the most predominantly used positive isolation is double block and bleed walls. This is most predominantly used and it is considered much safer because you have a valve here. If the valve is passing, you can check the valve passing from this drain point. So if this valve is passing, you can check it from this drain point. So this is much safer than other processes. And it is mostly given in most critical, high temperature, highly toxic, so high pressure. So such units or such process lines will have such isolation setup. Piping spec break. Spec break is given in a pipeline where the pipeline changes from a high pressure system to a low pressure system or low rated system, or a low pressure system is getting connected to a high pressure or high temperature system, and it will not be continuous. So their specification breaks will be provided. These are clearly noted on piping and instrumentation diagrams. And these specification break has to be clearly understood as they are extremely important in ASOP studies. Okay, so which you will be seeing in due course. So now we'll see examples of piping spec break. So here you can see there is a boundary line. This is of higher grade, this is of lower grade, because this high grade material is going to a low grade system. So there is a transition given. And if you see here, from low grade, it is getting into a high grade. So where the first valve itself will be made of high grade. So from here, the spec break is given. And of course, this will also reduce the cost. For example, here you have a high temperature grade, low temperature grade. This is high pressure and low pressure. So this valve is giving the passing the fluid to a low pressure system. There you need not provide material of higher quality. So because once the valve lets out, the pressure here will be downstream of the valve, the pressure will be lower. So we'll be having a lower grade here. Of course, it is safer to provide a higher grade, but it's not required. And especially in safety relief valves, you'll be seeing this, because safety relief valves relieve it to a flare header or a common header where all the PSV discharges are collected, where the pressure will be much lower than the operating system. So now you need not provide high pressure rated pipelines or fittings in the flare header. There, a low pressure system, the requirement for low pressure system should be met. So lower grade material is sufficient. There is no harm in providing higher grade material, rated material, but that is not required and will end up in increasing the cost of the project. But apart from costing, we need to clearly understand exactly from where. So you should not provide a low grade material in upstream of this PSV. It should be only in the downstream of that PSV. All these have to be clearly checked during HACCP study or during engineering review stage. Okay. So providing lower grade in place of higher grade will cause serious damage. That should be avoided. And now there are many utilities which are connected to a process line. So why utility is connected is, so we'll be using it for purging. We'll be using it during shutdown and startup. So at that time, what happens? So utility header will be of lower grade and process line might be of a higher grade. So you need not provide the entire utility header with the high grade material. So you will be providing low grade till this isolation, because this line will be used only during shutdown. So you have this wall which is getting exposed to the process line should be of high grade material, because process is of low grade. So here you will have positive isolation. So this we already saw, double block and bleed. So such isolation will be provided because this will be used only when the process is off. So in case of any line junctions, you will have different grade of fuels or fluids flowing into a single header. So one may be at a high pressure, one may be at a low pressure, or some would be higher temperature, some would be at lower temperature, or maybe based on fluid composition, the metallurgy may be different. So wherever it is given, the nearest point, so nearest point where it is getting joined will have that higher grade. Till that point, we'll be having that higher grade material. Okay, you can see here. So now we'll see how pressure safety valves are shown in P&IDs. So we are not going to show you entire P&ID. We'll show you the how exactly PSVs will be shown in P&IDs. Safety relief valves, pressure safety valves. So what they do in case of any over pressurization, they will relieve the excess pressure to protect the equipment to the flare header. They'll relieve the excess pressure to the flare header. So this is how a PSV is shown. You see from this line, this may be a line or a equipment. And PSV is also provided with bypass. These are purely for a decontamination purpose or during shutdown. It's used only for shutdown and maintenance. In normal operation, this bypass line of any equipment, especially PSV, is always kept closed and blinded. Okay? Because if it is not blinded and if these walls are passing, have failed, we'll have the fluid going to flare header. This is a loss for us. So this is to be kept blinded. CSO is nothing but a term. There are car seal open. Seal open. Okay, this wall should always be kept open. Should always be kept open. Because if these walls are kept closed, it will not serve the purpose. If this valve is closed, PSV is not going to pop up. PSV is not going to see the pressure. If this valve, downstream valve is kept closed, even if the PSV pops up, even if it relieves the head, excess pressure, the pressure will not be relieved to the header because this valve is closed. So it is always important to keep the valves in open condition for pressure safety valves. So this drain is given for removing the trapped fluids here in case of maintenance. During maintenance, what we'll do, we'll close this wall and then remove that gas here. We'll vent it to the safe location and this PSV will be dropped for maintenance. So that's why isolation valves are given. In few cases, there will be no isolation valves. They'll be connected to the equipment and that equipment itself needs to be shut down for maintenance of the PSVs. So PSV is a very important equipment in any process plant. So it should be properly operated. So you'll always have upstream and downstream walls, and these walls have to be kept open. Otherwise, it will not serve the purpose. And this is how the safety valve is given. And here in that circle, you'll also find pressure safety valve set point. At what pressure it will pop up. 10 bar, 8 bar, 20 bar. What's the pressure? It should pop up. And you see suction line is vertical. So if the suction line is not vertical, if it is taking loops, even then the slope is to be given towards the suction point because liquid accumulation should not be there. Gas pockets or liquid pockets should not get formed here. So same for discharge header. If you see this arrow we discussed yesterday, arrow is an indication of slope. Slope is to be given towards this side. Once it pops up, this line should not, this PSV should be at the highest point. Outlet should come down. If it is going up, if there is any liquid, there will be a backup and that will add additional back pressure to the PSV. So the discharge line should be freely drained to the header. Same is applicable for suction line. So this is how a typical PSV is shown in P&IDs. It will have its isolation walls, drain vent lines. It will have a bypass wall. It may or may not have a bypass wall. But what's important is keeping the walls open, upstream and downstream wall open in the PSV, which is in line. Okay, that is more important. So at times we'll be giving more than one PSVs. It might be of same capacity or it might be of different capacities. So normally one spare PSV is also given as a this in practice. So there will be two PSVs. In case of two PSVs, you can see here CSO open. It means that this PSV is in line. You can see here CSC. This is car seal closed. Okay. Sealing is nothing but a lock which is provided to prevent operation of the valve. It might be like a chain lock, or it may be a cable tie secured properly, or a lock itself provided. So this will be provided in process plans. So this PSV is in line. CSO is line. You can see the dark shaded walls are closed walls. At any point of time other than discharge wall, any point of time other than maintenance, the discharge wall should not be closed. If you are going to take in line this PSV, you have to simply open this car seal closed wall and then close this wall. That's it. So outlet valve is always kept open and it is closed in only during maintenance of the pressure safety valve. And bypass is also for maintenance of the equipment. If there is any steaming, venting is required during shutdown, at that time it will be used. So you can see now, this is how multiple PSVs are shown. So main thing is that it should be in line. You should not close the upstream and downstream walls. That is to be always kept open, and adequate slope is to be given for both inlet and outlet. If there is no slope, there will be liquid pockets or gas pockets getting accumulated in the discharge line that will prevent PSV from relieving the required capacity. That's why. So now, so we have seen PSVs, we have seen specification breaks, we have seen positive isolation. See, these are the few things which are critical for process safety. Now we'll see the control systems. So this is how a typical plant control systems work. We are not going to get into how this sensing element or the final control element works, how the control element works. We'll be seeing only the process control systems overview, process part of this. So this is a process, flow is coming here. You see the outlet, it may be a PT, FT, TT, anything, temperature, pressure, flow sensing element. It measures, it transmits that signal to a control element, where this control element will be giving input to this control element that will check the flow with the set point, and it gives input to this final control element that may be a control valve. If flow is high, flow meter senses the high flow, compares with the set point. Suppose I wanted to maintain a 10 meter cube per hour. Now it is 12 meter cube per hour. It compares 2 meter cube is higher. Then it instructs this final control element to reduce the flow. Then this reduces. Then here, once I achieve 10, then control valve will not take any action until unless the control element has compared the set point and the sensing element value, and if both are same, there will be no action taken. Okay, this is how basic process control loop works. Now we'll see the different important types of controllers. So this we discussed. Fluid flow is there, orifice meter, rotameter, venturi meter, anything, any flow sensor. We have the transmitter. It transmits that signal to the controller, and this controller is nothing but a software where it compares the set point and the value of flow from this orifice. If both are same, it's not going to give any instruction. If the flow is lesser or more than the set point, then controller will instruct the control valve to open or close accordingly to meet the set point. So this is how a basic flow control works, and this is similar for a pressure, temperature, everything. It senses the current value, compares it with the set point, then gives the instruction to the final control element. That is mostly control valve. So this is how basic process control loop looks like. So now we'll see what are the different types of control systems. You have feedback control, feed forward control, feed forward and feedback control, ratio control, split range, cascade. There are different types of control systems. Now, why control system is more important? Why we should understand the type of controller? Because day in and day out, we are operating the plant. And of course, so we should be aware what type of controller is there in the plant and how it works. And as a designer, we should be able to design the process plant with adequate controlling systems. So for that, we need to understand how different types of controller works and which controller suits our process. Okay, so this is very important. So first, we'll start with feedback control because this is the simplest process control scheme which is available. Now you have a vessel where a fluid is coming and fluid is going. LCV is nothing but level control valve. This nomenclature may be different, but what's important is understanding the concepts. Fluid is coming here, it's there in the vessel. You have a level transmitter. What we saw in the previous slide, we have a transmitter, and that gives input to a controller. So controller, I have already kept a set point. So maybe I wanted to operate the vessel at 50% level. So I have given the set point as 50%. It's nothing but a data input, just like typing in your laptop or computer or your mobile phone. Okay, you'll have a in that screen, in DCS screen, you'll have this controller. You'll give the input here. I want to maintain 50%, and if this increases, this controller will advise the control valve to close further because already it is 55. You please close because I have to maintain only 50. So if it goes by below 50, it will ask this control valve to open. It will tell the control valve to open. So this is how the process control takes place in the plant. Okay. So this is how it is also mentioned in the P&IDs. And now recalling P&ID legend. These are dotted lines are mostly for electronic signals. And this line where you have parallel lines, right? So you can see two different lines here. This is electronic signal coming up to the control valve. From control valve, you can see here, it is a parallel line. This is nothing but pneumatic signal. So instrument control valves are operated with the help of instrument air. So all are pneumatic system mostly. Of course, we have hydraulic systems too. So this electronic signal is converted to pneumatic signal here. So that with that help of air pressure, control valve operates, opens and closes. So this is the simplest control. So control action is taken to return the process variable to set point. So it tries to maintain the set point at 50%. So the main advantage is that it's simple. Uses only single control, single transmitter. So if there are other disturbances, so that will not be taken into account. If outlet flow is also varying due to some pressure differential or any issues, so that outlet it cannot control. So this is a simple control which only maintains the level with the help of inlet fluid flow. Okay. So the same can be replicated for outlet also. In few processes, we'll have this control valve in the outlet. So level will be controlled with the outlet flow. So that can also be there. So valve can be provided in the upstream or in the downstream. So this is what feedback. Controller takes the feedback from the level transmitter. So it compares, it takes feedback. How much should I maintain? But it is now not maintaining. So it takes a feedback and it controls the control valve to maintain that set point. Feed forward control. Feed forward control loop. So as the name itself says, feed forward. So whatever disturbances we are anticipating in the inlet, that will eliminate. So feed forward loop is a control system that anticipates load disturbances and controls them before they can impact the process variable. So here in this process, you are giving a fluid in and you are maintaining the fluid temperature here, and you are giving steam for heating the fluid. So if inlet flow is constant, there is no need of varying the steam flow, because for heating this much fluid, I'll be requiring this much steam, that is fixed. But what happens if inlet flow is varying? Then it will be difficult to control the steam flow if this control loop is not there. If inlet flow is varying, I'll be seeing this temperature and then adjusting this steam flow. So here what happens, I am sensing the inlet flow itself. Inlet flow, if it is varying, it automatically varies the steam flow. So if this controller is not there, what will happen? Fluid gets in, this temperature gets disturbed, and then I manually adjust the steam. So that's why now I know the disturbance is caused only by this flow of this fluid. So I'll directly control the effect of disturbance here. So I'll take the disturbance, flow has disturbed by 10 meter cube. Now flow has increased by 10 meter cube. Now you increase the steam flow. Flow has reduced by 10 meter cube. You decrease the steam flow accordingly. So this controller gives instruction to this steam. This is, we are avoiding any disturbance in the process. So whatever disturbances are in upstream of the process, we are taking a note of it, comparing, and then adjusting our process to accommodate that disturbance. So this is feed forward control. So I'm controlling the disturbance and well in advance. As we discussed, feed forward control, error is prevented rather than corrected. In feedback, error is corrected by taking feedback from the sensing element and comparing it with the set point. However, you see, for any process unit, the process conditions are very dynamic. We cannot take feed forward control for entire load disturbances. There will be many factors affecting the process. So only where we see a flow or pressure or temperature variable which has a major load disturbance, which is connected with from a different process where disturbance are predominant, only that can be controlled. So not all the inlets. Here it is very simple because we have only one fluid. There may be multiple fluids coming in. So not every fluid we cannot take and control. So at that time, what we'll do, we'll have the maximum flow or the maximum disturbance variable that we'll measure and control. So effect of other things, other will be negligible. So likewise, this feed forward control has a disadvantage. So in general, feed forward system should be used in case where the controlled variable has the potential of being a major load disturbance. So only major load disturbances can be taken into account for this feed forward. And again, feed forward, error is prevented. It's a preventive action rather than corrective action, which we saw in feedback control. So another control type is ratio control. A ratio control, as the name says, it controls the ratio of flow. It is basically used when two or more fluids are added to the process, or maintaining a correct air to fuel ratio for complete combustion, where two or more fluids are used, where a ratio of fluid is to be maintained. For example, you see here 2 parts of water and 1 parts of acid. So this is how acid you will measure, and here water comes actually. So based on that, control valve will open and will maintain the ratio. And here it is more clearly given. You will have a while flow or a controlled flow. So while flow, you exactly don't know how much will be the flow, but you need to maintain a ratio between these two fluids. So you will measure the while flow and you have a set point. You have fixed 50% while flow and 50% control flow. So based on this while flow, control flow is also regulated to maintain the ratio in the mixed flow. Suppose if you give 60-40, it will maintain 60-40 accordingly. So this is how ratio control works. And now this is the most important control and faster control, cascade control. Cascading is nothing but transferring the effect to the nearby controller or the connected controller. You're cascading the control. What happened here? Two controllers are used, primary and secondary. So we'll discuss with an example. Here you have a process fluid. It's a shell and tube heat exchanger where steam is injected to increase the temperature of the process fluid. Now, if you see, the main control variable which I need to control is temperature of the process fluid. So now this temperature is controlled with the help of steam. So what happens? Steam flow at this temperature senses the temperature. I know how much temperature I should maintain. So that set point is given to the primary controller. Now it compares, and what it does is it will give input to the steam flow. Now here this is secondary controller. So this will say, suppose I need to maintain 100 degree. This controller will say you maintain 10 meter cube flow. Now this compares this 10 meter cube flow with this steam FT, because this controller has instructed this controller to maintain 10 meter cube. And if steam is not maintained 10 meter cube, it will compare and it will give instruction to this valve to maintain the flow at 10 meter cube. So this is how it works. And now you may ask why this controller is required. This directly I'll give this temperature to the steam valve, as in case of feedback control. That is the simplest control. Now if you see this temperature measurement, once it gives the temperature input to the steam valve randomly opens and closes. In case of any disturbances in the steam flow, so this control valve doesn't know how much flow is going or how much flow is available. So if the steam availability is low, or if based on this steam valve operation only, this temperature is getting maintained, but this steam valve will not know what is the flow flowing through it. So it may immediately open and pass through more steam, and temperature may shoot up immediately, and the control will not be uniform. So what happens? We are giving a flow instruction. You please maintain this flow for this temperature. So this will give a more fine control, and also it will the action will be much faster. Once the temperature changes, immediately the flow is compared and immediately flow is increased. Here you don't know how much flow you have increased. Once the temperature changes, control valve will open or close, and it may go in excess or in lesser. So you exactly don't know the flow or how to control the flow. So this controller will help in a fine control over the temperature. So the main reasons for cascade control, it will allow faster secondary control to handle disturbances in the secondary loop. So what happens? It will always maintain the required input, required output. So here the temperature controller gives its instruction, maintain 10 meter cube flow, because this controller knows it has to maintain 100 degree with 10 meter cube. So once it continuously senses, if there is a reduction in flow, there may be any reason. Suddenly steam consumption has increased, header pressure has dropped, there will be disturbance in steam flow. This senses, and if it is not 10, it will immediately open the valve to maintain that 10 meter cube of flow. So this will allow the controller to take faster actions. And in case of startup, allow operator to directly control the secondary loop. So now you have a different, during startup, you don't have this immediate temperature coming. So everything will be a slow process. Manually, we'll start the equipment. At that time, this controller will be useful. He can give the set point, maintain 1 meter cube for 1 hour, and slowly he can increase. So this will give a finite control. If this controller is not there, he has to rely only on the valve opening. So during startup or shutdown, this will be much useful. So this is how cascade control works. nothing but cascading the effect to the secondary controller. So directly giving the temperature signal to this steam wall will only disturb the process, because once it get reduced, it will open or close and steam has to flow in, it has to sense, and then again it will only keep on adjusting. It exactly doesn't know how much steam has to be given. But here it is clearly sensed and we know how much steam has to be given, and action will be much faster, because this steam flow is also sensed. If there is any disturbance in steam flow also, this steam wall will take action, because this controller has already given input to this controller. So this way we'll be having a much better control over the process. Now we'll see split range control. So it's very common. We'll be using. It's now very common to see two or more walls used for the control. Okay, just imagine this is a flow. This is wall VA is routed to X and wall B is routed to Y. So whenever flow is very high, wall A will open first and will route it to this destination. And still, if the flow is further increased, this wall B will be used. Okay, it is nothing but the control is split between two control valves, two or more control valves. So now coming to this example, controller output is 0. That means valve A is fully open and valve B is fully closed. You keep open the valve A. Control output is 25. Valve A will open 75 and B will open 25%. So if it is 50%, both valves are 50-50. If it is 75, valve A is 25, B is 75. If it is 100%, valve A is closed and B is fully open. So don't get carried away with this controller output and valve positions. It is like based on process requirement, it gets open. So here we have not defined any specific process. It is if there are two valves to be controlled, we'll be using split range. So this is used where two or more control valves are used for controlling the flow, pressure, everything. So this is what we call split range control. So controller output is in percentage because it is advising the valve to open for that much percentage. So that's why it will be in percentage. So you can see here again dotted lines, instrument electronic signals, and here pneumatic signals. FC is nothing but the flow controller. Flow is split between two or more control valves. It may be of different, it may be 33%, 30, 66%, anything. Not exactly in multiples of 5. Okay, this is only for example. Based on process requirement, we'll be giving the controller outputs. So these are the important control types which are used in P&IDs. So now we have studied about the basic process control system. So these help to operate the plant in a normal way. So whatever we have discussed is for normal operation of the plant. So whatever we are going to discuss now, it is for emergencies. So emergencies may be high pressure, low pressure, high temperature, low temperature, high flow, low flow, high concentration, low concentration. So all these. So will be is emergency is nothing but any unwanted incident happening. Sensor failing, that is also an unwanted incident. So emergencies will lead to incidents. So we need to take safe shutdown of the process. So emergency shutdown system helps in stopping the process, isolating the equipment or stopping the equipment in order to prevent any damage or loss of containment. Loss of containment is nothing but fluids coming out of the pipelines. So if there is a high pressure and if you are not going to stop, equipment will get damaged, and whatever fluid is processed inside, if it may be of hazardous nature, maybe toxic, high temperature, high pressure, that may come out, and that will cause injury or even life loss. So in case of any emergencies, process should take shutdown on its own. So that's why we have emergency shutdown system. In process safety terminology, it is also known as safety instrumented systems. That is, we have certain dedicated instruments for shutting down the unit, the process, line, or equipment, maybe pump, compressor, in order to prevent further damage, any damage. So this is emergency shutdown system. So the main purpose is to safeguard man, machine, and environment. It is very critical. So if hot fluid comes out and if we get into if a person gets into contact, that will lead to an injury. Pressure is high, machine may get damaged. Temperature is high, machine parts can get damaged. Environment is concerned, we may release toxic gas. High pressure, line rupture, that may release toxic gas to the environment. So in order to avoid all this, emergency shutdown system is provided. Sensor senses abnormality and it activates the final control element. Basically, final control elements are not control valves, they are on-off valves. They are instructed only to open or close in case of emergency. Solenoid valves. Okay, it will power up or power off the valves. So what the emergency shutdown system does is it takes the process unit to a safe situation. It will shut down a part of that unit, or it may shut down the entire unit. It may shut down only that equipment which is having abnormality. So as far as emergency shutdown system is concerned, there will not be any manual intervention. It's a fully automatic system. So you cannot manually operate that emergency shutdown systems. It must be kept in auto and it should be a fully automatic system. So now we'll see. So we have a vessel here. If you see, so then what we'll also understand what's the difference between basic process control system and emergency shutdown, ESD, emergency shutdown system. So you see a vessel here, you see a valve here, you see a valve here. You have two PTs. One is connected to the basic process control system. Other is connected to the emergency system. Normally, for normal operation, we'll be operating this PT. If pressure increases, this will operate the valve and it will be released. If level, this is reducing the level. So what happens? If it is increasing, this will operate. So this is only for operation. So if there is any failure in this pressure sensing, or if the pressure is continuously increasing beyond the control range of this control valve, what happens? This will come into a picture. This as a separate sensor and a separate actuator. Okay. What happens? Even after controlling, if the pressure is still increasing, this fellow will come into action and he will instruct the system to close the valve. Okay. So this is how it happens. So these both are separate systems. This is a control system, this is a shutdown system. Okay. So So this is how it works. We'll have a separate sensing element and separate final element. So this should not be mixed. Same PT should not be used for both shutdown and control system. It must be different. And in further what we'll not only rely on one PT, we'll have two or more PTs, and we'll have logics like 2 out of 3. If 2 out of 3 PTs senses high pressure, then this shutdown should happen. So that logic also we will implement. But the basic understanding is basic process control system and shutdown systems are totally different. So once BPCS fails and conditions are escalating towards an emergency situation, this safety system will take care. Okay, here it is also not reliant on one PT. We'll also provide additional PTs, additional sensors, TT, FT, whatever it may be. So we'll implement logic 1 out of 2 or 2 out of 3, okay, based on our process criticality. So this is what emergency shutdown system is. That is also clearly shown in the P&ID. So now, we have seen how control system is happening. So this is nothing but a depiction of process safety incident. What happens? The first level of defense from bottom to top is basic process control system. So this basic process control system helps us to operate the plant within the specified range. And this is shown in P&IDs. In case if it is escalates, there will be operator intervention. If alarm is coming continuously, then operator will take shutdown. And at times, operator may also fail. So what happened? We'll have an automatic system to shut down the plant or a part of that plant or equipment. So trip level alarm. This is process alarm. So just to understand, we have to maintain the flow at 100 meter cube per hour. If it goes to 102, 101, there will be alarm. Operator will take action. If it goes to 120, equipment should stop. Wall should close to safeguard the downstream equipment. So that is trip level alarm. Okay, alarm values will not be specified in P&IDs, but high, low alarms requirement will be specified in P&IDs near the controller. So now, then safety instrumented system, emergency shutdown system will take care. So these are preventive actions which are inbuilt in the P&IDs and also in the plant systems to prevent the incident from happening, high pressure situation from happening. Next is mitigate. It has happened. Now we'll have the relief valve. So now you see, even if your safety system fails, your relief valve is still there to reduce the damage. That's why we specifically saw the relief valve details. How the valves, inlet and outlet valve should always be kept open. So now, even if this fails, you will have the relief valves which relieves the pressure. And beyond this, we'll have the dike, that is, if there is any leak, that will be controlled. And after that, we'll have the emergency response. It is nothing but our action where a fire or gas leak is occurred, and we'll have our protocol to, we'll have the procedure for firefighting, evacuation, everything. So this is the last thing which we should be doing. So majority of the part is taken care here in basic process control system. If we operate the plant within the process alarm limits, nothing is going to happen. but it is equally important to keep your safety shutdown system and the relief valves in line. So there should not be any abnormality in this relief valve system or this safety shutdown, this emergency shutdown system. Okay, all these are given in up to relief valves. Everything is engineering control up to this relief valve, because that is also given in P&IDs. So this is about process safety in P&IDs. Okay, so we have come to the end of that session. Hope you would have understood the concepts. So we'll just have a quick recap of what we learned today. We have learned different piping arrangements, especially isolation types, positive isolation and valve isolation. Positive isolation is given where equipment is to be handed over for maintenance or person enters into the equipment for inspection. That will allow other incoming or outgoing fluids from getting into the vessel. So there positive isolation is done by providing a blind flange. Blind is inserted in the line. So you're stopping the line. Then we stop piping spec break, where a low grade or high grade material gets connected, fluid gets connected, and the nearest point will be having a higher grade to prevent damage. And then it will be having a lower grade after positive isolation. Mostly it is used only during shutdowns. Then we saw different control systems, important types of control systems and how they are used. Then we saw PSVs, where pressure safety valves, how it is shown in P&IDs, significance or the importance of the isolation valves of PSVs should be always kept open. Then we saw emergency shutdown systems, which prevents or automatically takes shutdown in case of any exigency or excursion in temperature, pressure, flow. So any uneven, unwanted situation. Then we saw how the process safety requirements are shown in the P&IDs. So thank you all. Hope you enjoyed. Please post your queries. We'll be happy to clarify.
Thank you, sir. The training was so insightful. Thank you for such an interesting session. Now we can proceed with the Q&A session. Hope you all posted your queries in the Slido link. Now we will address one by one. The first question, will P&ID diagram show dimensions? What is the difference between scale and dimension? Provide some example.
So in P&ID, we'll show only the dimensions of the equipments. Suppose I have a vessel, diameter is 2 meters, height of the vessel is 10 meters. Only that dimension is mentioned. No scaling is done. That is, the length of the pipeline or the unit plot plan is 50 square meter. So such scaling is not done in P&ID. Even pipeline length is also not mentioned in P&IDs. That will be done in further engineering. The isometric documents will have this length of the pipelines.
Why positive blind is required even though we have isolation valves?
So isolation valves, what happened? Those are mechanical equipments and it has movable parts. It may fail. We have seen in industry where few valves are passing in the sense it will allow the fluid from one side to other side even in closed condition. So even to avoid a 0.1% chance of failure, we'll close the valve and then provide blind, because in case of toxic gases getting into the equipment where a person is inspecting, that may lead to life loss or a serious injury. That's why we don't rely only on wall. For positive isolation, we need to put a blind, block the line, or you remove the spool so that nothing is connected to the vessel or the equipment in which we are working. And that is applicable for electrical connections also. So if you don't keep on working on your mobile or suppose any electronic, suppose a TV, you will not plug in. Even though you have a switch, you have switched off the TV, you will remove the plug and then work on it, right? It is similar to that. Plug is you switching off, it is like closing the wall. Removing the plug from the socket, it is like positive isolation. You have isolated all the energy sources connected to it, so which is the much safer condition. So that's why positive isolation is required.
Okay. One participant wants to understand why can't valves be made so efficient that we don't need any kind of positive isolation?
And yes, nowadays we do have technologies where the leak rate or the passing is almost nullified. But yes, uh, we cannot you cannot fully eliminate because a new wall may not pass. Once it is in operation, there may be few damages. After a few years, you don't know exactly what the wall condition is. So that's why we always rely on positive isolation. We don't rely only on isolation walls.
Okay. What is low grade and high grade? Could you please explain in detail?
See, low grade is nothing but, so what happens, we have different metallurgies. So we'll have carbon steel for low temperature or low temperature fluids. You'll have stainless steel, you'll have alloy steel for high temperature fluids. So when there is a pipeline juncture where this low grade material is to be added to this high grade material, that happens mostly in shutdown only. Very rarely it happens in a continuous plant. So that is, in that line you may add nitrogen to push out the hydrocarbons during shutdown, so during maintenance. So at that time what happens, you need not design the nitrogen line for that, nitrogen line for that ss grade with ss grade material, that will add to the cost. But nitrogen lines first wall which is exposed to that which is connecting to that high grade line, stainless steel line, should be of stainless steel. Even though nitrogen will not require stainless steel, still we'll provide nitrogen. That first wall is to be made of stainless steel, because that is getting exposed to the higher temperature condition. So this is what the spec break is. So we should not provide lower grade material which is facing a higher temperature conditions, even where the interface should be of higher grade material. That's the main purpose.
Okay. What is the criteria that a line must satisfy to have either a single PSV or two PSVs?
So there are many conditions which are to be considered. So if I'm able to, if the line is of continuous operation, then I'll be giving additional PSV, two PSVs, A or B. Because if it is in continuous operation, I can't isolate the PSV, right, for maintenance. At that time I'll be giving additional PSV of same capacity, so that I take this in line and hand over that PSV for maintenance. So that is the basic requirement for two PSVs.
Okay. Is this cascade control similar to forward control, but it automatically works?
Yeah, it is slightly similar to feed forward control, but in feed forward control, what happens? You will first measure the disturbance, and with the help of disturbance, you are maintaining the required parameter. But here you are not you are not you are not controlling the disturbance. Here you are controlling only the process variable, which is in the downstream of the control. So feed forward is different and cascade is different.
Which is more advantageous, either ratio or cascade control?
No, you cannot compare a ratio with cascade control. Both are different actually. Uh, the purpose for the control is different. The ratio is basically where two or more mixtures are mixed or it gets into a same process. The example which we saw for cascade control is a heat exchanger where the process fluids are not mixed. Their ratio is not maintained. We'll only maintain the required flow.
Next question. What are the applications of split range control?
See, few application is you have a vessel, you need to maintain a pressure. So you'll have two control valves. One control valve is giving injecting the fluid to the vessel to maintain the pressure. Other control valve will relieve the excess pressure. If the pressure is low, this control valve which is injecting fluid will open. If the pressure is low, this excess flow control valve will be always be closed. So where the control is split between the two control valves. In case of high pressure, the injecting control valve will close and the venting control valve will open. So there are many such applications where split range is used. Or you have a flow control valve. If up to 10 meter cube, I'll put to this unit. After 10 to 15 meter cube, I'll put to this unit. So if it is more, then I'll put it to the tankage. So you'll have different flow directions for a same fluid. At that time, you may use this split range control valves.
Okay. The next question. Difference between pressure safety and pressure relief valve.
Both are of same purpose. Both are of same purpose. Actually, both are used for relieving excess pressure. So both are, of course, they are both used. The purpose is same actually. There is no specific difference between PSV and PRV.
Next question. What is a utility?
Utility is nothing but air, water, or any chemicals, additives, which are supplementing the process, which we use for the process, but it is not directly mixed or connected to the process. Example, instrument air is a utility for us because it is used for operating the control valves. Cooling water is a utility for us because it is not directly getting mixed with the process, but it cools the process fluids. So such fluids are called utilities.
Okay. Next question. What is a single block and bleed and double block and bleed? Can you please explain?
Single block is nothing but single wall with a bleed in. I'll just show you this presentation. I think it will be clear. Graphical representation will be much easier. Here it is single block and bleed. Bleed is nothing but a drain wall. single block bleed. Here you see double block and a bleed. So double block and bleed is a much safer than single block and a bleed. But of course, it depends upon the process or the hazard in associated with the process. Here, the online process may be much more hazardous than this online process. So a single wall and blind is provided. So this will be much more toxic or much more hazardous. So double block and bleed is provided. So this is what single block or double block is.
Okay. In industry level, which loop is efficient, closed or open, and why?
So, see, open loop doesn't control anything. First of all, it is only an indication. So only closed loop controls. So you cannot add efficiency or seek efficiency between open and closed loop. Open loop is nothing but it will not control. It doesn't have any control. It has only indication. Closed loop is like you're closing the loop. You are putting a sensing element. You have a controller and you have a controlling element, final control element. The loop is closed. There it is only sensing and giving the value. Open loop.
Okay. How to calculate ratio in control loop?
So that we should only set. So during the process development itself, it is given. During simulation, it is identified. So I'll be adding A 5%, B 95%. Entire ratio is defined in the process scheme. So in simulation, it is identified.
The next question, will P&ID show type of controllers?
Exactly, it will show the type of controllers. We have seen how a cascade control looks, how a ratio control looks. We have only seen that part of that P&ID. So every P&ID will have the type of controller. By seeing the type, seeing the P&ID, you can identify.
Okay. The next question, where is slope shown in suction and discharge of equipment?
Slope will be indicated. Just a minute, I'll share that screen. So you see this line, right? This small triangle, right angle triangle. So the lowest part is it's sloped towards this. So this is sloped towards this side. This is not typically top side. It will be horizontal only. It is sloped towards this flare drain safe location. It is sloped towards this. So this is sloped towards the bottom. This is how the slopes are indicated. At times you'll also see slopes indicated like arrow and a slope written over it. So there are different ways of indicating the slope, and this is one type. Now you can see.
Thank you. The next question, whether an equipment can be placed on a slope? How about the balance of equipment?
Equipments will never be placed on a slope. Only lines will be inclined to avoid any pocketing.
Okay. Next question, if slope is there in a package, consider skid. Then if the slope is incorporated in skid or not?
Repeat, please.
If slope is there in a package, consider skid. Then if the slope is incorporated in skid or not?
It must be incorporated in the field. If slope is mentioned, that is to be provided.
Okay.
It has to be taken forward to the isometrics. Isometrics should be made keeping that note in mind, and then again the same has to be executed in the field also.
Okay. Next question, what is differential control, where it is used?
control as such, differential control is because differential is accompanied by whether it is differential pressure, differential flow, differential temperature. Instead of suppose if it is differential pressure, instead of maintaining a single pressure, I'm sensing comparing with two PTs, I'll maintain the difference between the two PTs constant. So that is differential pressure. Ultimately, the input for the controller will be one thing. That is, instead of pressure, the delta P goes, differential pressure goes. That's it. Instead of flow, differential flow will go.
Next question. How does temperature relief valve and pressure valve differ?
See, temperature relief valves, actually, it relieves the excess pressure which has been formed due to rise in temperature. Okay. So once it gets heated up, there will be expansion, right? Any fluid. So only that it is going to relieve. So ultimately, it will relieve the excess pressure formed. So temperature is high, there will be expansion and there will be pressurization, and that is relieved. But the main purpose is it will, on high temperature, this will pop up.
The next question. What are isolation valves?
Isolation walls are walls which isolate the equipments, instruments, anything. It will just isolate. If you close that, that equipment will get isolated.
These are all the questions in the Slido link we provided. Participants, if you have any further queries, please post in the Slido link, or else you can unmute yourself and ask here, or else post it in the chat box.
Hello, sir.
Yes, please.
Good evening, sir. I asked this question of whether type of control will be mentioned in the P&ID.
Yes, yes. Yes, please, yes, please.
Yes,
proceed.
my doubt is I got idea like cascading, and we'll get to know by seeing whether it is cascade or other control strategy. But it will not mention whether it is proportional or proportional integral or proportional derivative.
No, it will not be mentioned. Only by seeing the control lines, you will be knowing it. That's why we stressed on understanding the type of controllers used in P&IDs. So once if you see the P&ID, you'll be able to decode. Oh, it is cascaded. There are two controllers connected. So then it is cascade control. Now you will be able to relate it.
Yes.
It will not be explicitly written. It is cascaded. It is ratio control. At times, ratio control will be mentioned, but not all the times.
Okay. Thank you. Hello, sir.
Yes, please. Yes.
Yes, sir. Conventional drawing sizes is also asked in the last assignment. Can you please explain that, sir? Like A1 size in drawing preparation, something like that. It is being asked in the last assessment.
Okay. So normally what happens, A3 is the most preferable size for reading and handling P&IDs.
Okay, sir. For drawing, it is A1.
That is for the plot plan and all you'll mention, right? That will be shown in A0, A1. But normally P&IDs, it will be in A3.
Thank you, sir.
Participants, if you have any further doubts or clarification, you can raise your hand or unmute yourself and speak, or else you can post in the chat box. Hope there are no further queries. We can wind up the session for today. Thank you, sir. Thank you. Thanks for the insightful session, and thanks for your valuable time. And thanks for your patience in answering all the participants' queries.
Thank you so much.
Thank you, sir.